So, as you can see, there's two types of circuits, series and parallel. This is how you write a battery right here. The shorter side here is negative and the longer side is positive, and that is definitely a battery. A battery might look like this, like a AA battery that goes in a toy or something. And this would be the positive side and that would be the negative side. But not all batteries look like that, because there's car batteries and there's watch batteries and there's all kinds of sizes of batteries. So, but in general, in electronics, we draw a battery like this. Okay, so that's how I'm going to do it. And then you could draw a resistor like this. That's how you draw a resistor. Technically, it's just a line, and then it goes like this, and it goes like that. Um, that's how you draw a resistor. Now, so this right here, that is a battery. And then, and usually, there's some voltage next to it like that. And right here next to that, there's usually some resistance. A resistor may look like that, but sometimes they do draw them like this because it's a light bulb. So they go like this, and they might put a little circle around it like that. So it's like a little resistor right here. Notice that little squiggly line like that? It's right here. And they just draw a circle, and that just signifies there's a light bulb. And sometimes there'll be little lines coming off of it to show shining, but it's the same thing. So this is the same as that. They're both the same, except this one gives off light and this one doesn't. This one just gives off heat, and this one gives off light. Although a lot of light bulbs give off heat as well, but they give off light, which is kind of cool at the same time. Let me erase this with my little eraser. And a series circuit looks like this right here, where you have electricity. Technically, electrons, negative electrons, will flow this way, and then it will go through another resistor, and then come back. And then they come back to the positive side, because this negative electrons are attracted to the positive side, and they go all the way around. So that's how we do that. In parallel, we have a battery. Okay, so same thing. It's got a positive side. It's got a negative side. We'll do a 12-volt battery. And it will go through a resistor like this. And by the way, in general, usually when you write resistors, you write like how many ohms they are, next to them. So I'm doing that just because I should be doing it. If we know them, we write them down. But if you have a second one, we draw it like this. And let me show you the difference, what this does. So let's say this is a 6 ohm resistor and this is a 6 ohm resistor. Now electricity travels from the negative side and it comes down, but right at this point right here, some of the electrons go this way, but some go this way. See, that doesn't happen here. All the electrons travel through this, then they all have to travel through here and come back around. This one, they get to split up, and some will go through this one and some go through this one, right? And then they meet back up here, and then they all join together in this wire and come back. That's important because if you note this, if I cut this wire off, so this wire doesn't work anymore, then electrons can't travel this way. So this will not work. Oops, let me write a pen. So this won't work right here. But this one still will, because electricity can still get there and go this way and go through this one. So if you have Christmas light bulbs, a ton of them, you have a ton of Christmas light bulbs. If you have this set up and one breaks or is broken or you take it out, the others still work. This one right here, if I take this bulb out, so if I take this bulb out, then electricity cannot get through this one, it cannot do it, and then it can't go here, so then all of them stop working because none of the electricity can get through. Go to our construction kit here. And so if you're drawing this, you go here, and let's use a light bulb instead of a resistor. And then let's do another wire. And let's do another bulb. And another wire. And I'm going to do another wire just so it looks nicer here. There we go. Look at that. Bulbs are working. I got 2 bulbs. If you want, you could put a switch. If you want to switch them off and on, there we go. And anybody know if that's series or parallel? Anybody? into chat or anything? Let's see. Where is there chat here? There's chat here somewhere. I can't even see the chat. But that is a series, okay? And let me prove it to you guys watching. Look at that. I disconnected this bulb and nothing works. Nothing works. Okay? That's definitely series. See, now it works. Now watch this. Let's disconnect this. And let's see if I can make this let's make this a parallel. So here's one, right? Actually, let me disconnect this one. I'm going to make it look a little prettier here. So it looks more like my drawing. There we go. And my drawing then had this one, right? And then I'm going to put this wire here. And then I'm going to put this wire here. And then I'm going to put another wire here. I could just put this wire right there, but I'm trying to make it look more like my drawing, you know? There we go. Now look at that. If you look, the yellow lines are larger. So that means they're brighter. So in this setup, the electrons are moving faster. It is brighter. And watch what happens when I disconnect this. The other one still works. If I disconnect this one, the other one still works. Because electricity finds a way to go through the other one, right? So this would be parallel, okay? And that's about it. Now for today's assignment, you're going to go to your classroom, go here, and to get to that lab, just click this, and that'll bring you to this lab right here. So just click that. Follow along this worksheet. You can print this. You can use some app. If you have some app and you know how to write on this with an app, go ahead. Go ahead and do that. If you want to print it on paper and write on it, that's fine. If you just want to write this all separate on a separate sheet of paper, like in a notebook, and then take pictures of your notebook, that's fine too. Whatever you want to do, as long as the work's done. And just follow along, checking all these stuff. It says draw a circuit here, and then you're going to be talking about conductors. So it says go to the grab bag, and it says try different objects. Which objects are conductors and which objects are insulators? So to find that out, all you would do is take a very simple circuit. That's what they want you to do at the beginning, and connect a wire and make a bulb, and then get a wire, and let's get another wire here. And they want you to try different stuff to connect here. So, for example, what happens if I put a coin? Will it work? It works. Okay. That means it's a conductor. It conducts electricity. Does a paperclip conduct electricity? I think so. It is metal. Yep, it does. So metal tends to conduct electricity, right? Does a dollar bill do it? I don't think so. I think it's paper. There you go. That's not going to work. So that's an insulator. That is an insulator because it's made out of paper. I think that should not conduct electricity. It's not. It's an insulator. So that's an insulator. So that's what you're going to be putting on your assignment right here. What things are insulators and what things are conductors? What things conduct electricity, lets electricity flow? Which ones do not? And then what do they have in common, so on and so forth. And that's it. That's the whole assignment right here. The rest of it is making a series and a parallel circuit, which I kind of just went over.